Hey, how you doing? My name's Elton, and welcome to the show. So this episode is rounding off the look we've been having the last few episodes, all about service mesh. Today we're looking at the service mesh interface. Slightly different episode today because usually what I do in these shows is I try and demonstrate a particular technology or a particular approach with a bunch of stuff in GitHub so you can try it out yourself, show you how it works, give you a kind of fast track to get you a feel of how you use it, why it might be useful. Today's slightly different because it's more a case of what state the SMI is in, the service mesh interface, this abstraction. So the whole idea of the service mesh interface is to take the features that you get from a service mesh and define them in a generic way. So rather than defining Istio resources or Linkerd resources, you define these kind of generic resources. That's what lives inside your application manifest. That's how you model your networking. And then you can use different types of service mesh and just apply the same thing. But today we're going to look at a couple of different examples of service meshes that work with SMI. So we're going to look at Traefik Mesh and Consul Connect. And we'll see that actually the SMI stuff is not quite as far along as the website might make you think. So you're going to see some demos today, all the usual stuff, but it's not going to be the fully fledged thing that we've seen with Istio because I think some of the implementations of SMI are not quite there. So I'm still going to give you the tools to evaluate it and see how this thing goes further on. Okay, so I'm going to switch to code in a second. Everything's up and running, ready to go. Before I do that, I'm gonna run my advert. Oh, I should say the big news today is that my book is out. So Learn Kubernetes in a Month of Lunches is out now. I finished working on it about 6-7 months ago. So that's how long it takes to actually chop the trees and print it. So you can get your copy now. So at the end of this month, I'm going to take a break on the container show. And I'm going to do a live stream of that book. So if you go to kiamol.net, K-I-A KIAMOL.net. There's a link coming up shortly. That's where you'll go for all that stuff. So I'm going to do a chapter every day. So in April of this year, starting 2nd of April, 2021, subscribe to the channel because the first one will kick off. I'll be doing an episode every day next month. And if you're new to Kubernetes, by the end of next month, you will know it like a pro. So that's for later. Now, today's service mesh interface. I'm going to switch to my other camera. I've got a new advert for you. So I'm going to roll the advert while I pull down my green screen and wiggle my microphone. And I'll see you in about 28 seconds. You're watching Elton's Container Show with your host, that's me, Elton Stoneman. If you're enjoying these live shows, you should check out my video courses on Pluralsight. I've authored tons of courses there with lots of content on Docker and Kubernetes and the container ecosystem. And if you come from a .NET background like me, you should check out my Udemy course, Docker for .NET Apps, which covers everything you need to know for running .NET apps in Linux and Windows containers. And if you're more of a book reader, then check out Learn Docker in a Month of Lunches and Learn Kubernetes in a Month of Lunches, both of which are published by Manning. And now, back to the show. Okay, and here we are. So everything today I'm going to be doing with Kubernetes. So the same things that we're going to be looking at. So the Traefik Mesh and Consul Connect. They both use Kubernetes custom resources to define everything. The SMI is based really on top of Kubernetes, so it defines things in this abstract way using custom resources to model your networking. So everything's going to be using with Kubernetes. I'm going to be using Kind instead of Docker desktops because I've got two different clusters. I'm going to have one with one service mesh and one with another. So a whole bunch of links for you today. My original plan when I did this episode is I was going to be using OSM, which is the service mesh interface. Now, where's my cursor gone? Let's try that again. That's disappointing. So the service mesh interface is the spec. So all these links here. So all this stuff's up on the show. So you'll see all these links when you go to browse the show for this episode. The SMI spec is on GitHub. So that's what's defining the YAML specification for the different resources. OSM is the open service mesh. It's like the kind of reference implementation of SMI. So the latest SMI spec is usually found in the OSM as the reference implementation. I couldn't get it to work. So with my demo application, everything is working fine except for I'm still running my database inside a container. And the networking model, you can kind of block access to different callers for your services. I couldn't get it to work with OSM for TCP traffic. It was fine for HTTP, but with TCP traffic it blocked everything, and then I couldn't get it to open anything up. So OSM is still in beta stage. Like I said, I couldn't get it working with my demo. It does work with their own demo application, but I put a halt on that and I moved on to these two alternatives. So that's really the promise of SMI. If I click this link, you'll be able to see is that there's a whole bunch of different things that implement it. But if you look at this picture, that's a slightly rosier picture than the reality, which we'll see in this episode today. Okay, so that's enough of the preamble. So prerequisites, if you want to follow along, so you need Docker, you need Kind if you want to have multiple clusters. You don't need to do that. You can just tear everything down in between clusters, in between demos, but it's just easier for me to have separate ones. So I've already created that. If you don't know what Kind is, it stands for Kubernetes in Docker. It's a command line that you run, and it runs an entire Kubernetes cluster inside Docker containers. So you can switch between different nodes. You can have different clusters running different versions of Kubernetes. It's a super nice tool to work with. Okay, so let's go and switch straight to the demo. So I'm going to be using this context here. So this is my Kind cluster that I'm using for the first set of demos. There's nothing running so far. I'm going to deploy my demo application. It's the same rubbish demo app that we've seen quite a few times here. I'm using customize for the definition just to make it easier for my different deployments. And that's it, it's up and running. So I've got these two backend services that list out products and stock. I've got a backend database that they both consume and a front end website that talks to the API. So pretty standard thing. If I look at the pods to make sure everything's been pulled and it's all up and running. So yeah, so containers are creating. So Kind, because it lives inside Docker, it kind of shares the image cache, but it needs to make sure it's got the latest version of everything. So let's just make sure they're all up and running now. So we're just waiting on the website, so that's good. And let's switch now to my node port service. One thing about Kind, I don't always use Kind. I usually just use Docker Desktop. Docker Desktop's got a really nice mapping for Kubernetes load balancer services. If you publish a load balancer service in Docker Desktop, it takes care of the networking, so you just browse to that port. So you don't need a different set of YAML between your local deployment and your live cluster. Kind doesn't support that so easily, so you tend to use node ports, which is fine. Just means you have a different definition for different environments. Okay, so here's the demo app. You've seen it before. It's like, I'm not going to spend too much time on it, but all this information lives in the database. It gets pulled out by the different backend services, and the website calls them both and uses them. So there's a various amounts of communication at different levels in this app. That's it at the moment. So it's just Kubernetes services, talking to pods in the background, nothing special. So first thing I'm going to do is I'm going to install the Traefik Mesh. I keep saying Mash. It was originally called like Mash with an A and an E run together. And then they renamed it because no one could pronounce it, but now I've still stuck to calling it the old way. So it's installed with Helm. So it's just a Helm chart. Let me clear this down. I've already got the repo installed. I've probably already got the repo updated, but these are the instructions you can follow along yourself. So that's all looking good. So Helm just stores that definition up in a repository. So it's just a bunch of YAML files that are going to be brought down to my machine. So I'm going to install it into its own namespace. I've got a specific version there. So I'm using the latest version right now. But again, if you go and do this in the future, you can use the same version that I'm using. So Traefik started off as there are different products from the Traefik team. One is the reverse proxy, so you can use that as an ingress controller. We've covered ingress before in this series, and we'll do a lot more of that in the Kubernetes series. The idea of that is it's a single entry point for your application. It routes traffic to all your containers, all that sort of stuff. And then there's this new thing called Traefik Mesh, which is a service mesh component. So it's a separate thing to your ingress proxy, but it's published by the same team. It's really nice because it uses the service mesh interface for all of the traffic modeling, and then it layers on some features of its own, so it does things really nicely. But it works in a different way from the other service meshes because it doesn't inject a proxy pod, a proxy container into your pods. There's a proxy pod running as part of a daemon set across your node, and you explicitly direct traffic through the service mesh instead of it being kind of automatically enrolled. So whenever your client makes a call to a server, like it's intercepted by the proxy and that applies the rules, you're explicitly routing through the proxy, which still has all your centralized rules, but it means that you don't have these proxy containers running in all of your components. Okay, so let's clear this down and see what's actually deployed. So if I look at everything that's in that namespace, ton of stuff as you would expect. There's Jaeger and Prometheus and all this sort of discoverability stuff that you would expect to see. Not going to demo all of that today, but check out the Traefik website for all of that information. And then if I look at the CRDs, so this is the custom resources for defining your network model, you'll see they're all part of the SMI. So these HTTP groups and TCP routes, they're how you control access to your different components. There's traffic splits, which allow you to do your traffic routing, and then targets, again, as part of that ACL model. So the way that the Traefik integrates with Kubernetes is it uses the standard SMI spec and then implements it in a slightly different way to anything else because it doesn't have those proxies running as sidecars in the pods. The way you actually enlist your apps to the proxy is by explicitly changing the destination of the service when you're making a call from your client. So, as an example here, if I was currently talking to my service at .svc.cluster.local, so a standard Kubernetes DNS name, I replace service.cluster.local with traffic.mesh. And that means it's going to go through the traffic DNS layer, and it will apply its own routing rules instead of just going through the Kubernetes service. So that's what I've done in here. So this is my web API definition. Let's close the terminal down and get a little bit of space. So my original definition, everything was products API .widgetario .service.cluster.local. So it was just using the Kubernetes addressing. All I've done is replace that with .traffic.mesh. So now the networking will be routed through the traffic proxy running on the nodes. There's a daemon set that runs on across the cluster, so every node has a single proxy pod. So instead of having a proxy container in each of your application pods, you have one proxy pod on each node, and that takes care of all the routing stuff. So you have to explicitly kind of direct traffic through the cluster, and that's how you do it by using this traffic.mesh fully qualified domain name instead of the ordinary Kubernetes domain names. Okay, so let's open this up and go and get this deployed. So firstly, I'm just going to use for the web application. So I'm telling the web API, I'm updating its configuration. So its endpoints for talking to the two backend services, they're now going to be routed through the mesh. The backend services aren't going through the mesh to talk to the database yet. We'll do that further on. Miles says, hello, hello. So if I'm going to roll out my application, because I've updated the config, actually this application does watch for changes of the configuration file, but it takes a while for all that stuff to filter through. So seeing as we're not in production, I'll just restart that and check those pods are starting nicely. So yeah, it's been running for 10 seconds. It's all good. Okay, so now if I go back and look at my application, what I should see is I should see all the data coming through. And there we are. There's my all the information that comes from the back end. So that's all working correctly. So my website is now talking through the mesh to my backend services, but without any configuration. There's no envoy proxy. There's no extra container running in the application pods. Oh, I meant to show you that. If I look at the pods again, without the watch flag, we'll see that everything's just got a single container running in the pod because we're not routing at that level. Okay, and I can double check that's working as expected. If I clear the screen here, if I'm running an exec call inside that web component, so execute call inside that container, I'm just going to do a wget on my ordinary Kubernetes DNS name. So making sure I can reach that service through Kubernetes, because that's the other good thing about the traffic mesh is that it doesn't replace everything. So it's actually quite easy if you're having problems to switch back to the ordinary Kubernetes thing. So this is the response that comes back. I forgot my shortcut. There we are. That's the response that comes back from my stock API when I call it using the Kubernetes address. And if I call the same thing again from the same pod, if I make a call via the mesh, via the traffic mesh, I'll get the same response back. So everything's working as expected. The IP addresses are different because it's being routed through a different networking stack effectively, but the end result is the same. My web component is talking to my backend APIs, but now it's being routed through traffic, so I can apply those rules and enlist all the features that I would expect to get from my service mesh, which is the next thing that I'm going to do. So close the terminal here. There's a couple of things you can do with the traffic mesh that you do with annotations inside your Kubernetes model. So before you get to the SMI stuff, you can bring in some features that traffic offers you that you can't really model in SMI yet. So SMI has this kind of core feature set that it's trying to model. So no, there is no envoy. It uses its own proxy implementation. So if you want to model everything, there's a kind of gap between I am the service mesh implementation. I offer all these features. A subset of those are coming from SMI, and the rest I've got my own way of modeling. We saw that with the Linkerd episode. So Linkerd uses SMI for traffic split, or it supports SMI for traffic split, and then it has its own custom resources for all the other things. So if you are looking at the SMI, this is one of the things you need to bear in mind. There's going to be a gap, and you're going to be working with two separate models effectively. So the way that traffic does that for annotations, I'll zoom this in. So it does things like retries, circuit breaker, and rate limiting. Really nice features to have at your networking level to say, if there's a call that's failed, just keep on retrying it. But add a circuit breaker in there so that if there's lots of failures that don't all suddenly cascade. The way you do that is with annotations inside your Kubernetes model. So that's a separate thing from your other parts of your service mesh, which you're using with SMI. So access control and traffic splitting, which we're going to look at here, that's all using SMI. So far, when I did my traffic deployment, by default, ACL access control is turned off. So anything can talk to anything else. it's not being controlled explicitly through the mesh. If I want to change that, I can make an upgrade to my mesh. So what I'm doing here is exactly the same Helm command, but it's an upgrade rather than an install, and I'm setting ACL to true. So what that's going to do is take my existing mesh deployment and effectively turn on ACL. So now there's a default deny. Nothing will be able to talk to anything else unless I explicitly allow that traffic. So this is one of the really nice features that you get with SMI and with service meshes in general. You get this really fine-grained control over which components can talk to other components, and it helps you really narrow down the attack surface of your application. So, if you've got a potentially rogue front-end app, you can't get to the database from that. You can only get to certain points. Okay. So let's have a look at that now. If I try and browse to my website now, I get this completely unhelpful 404 error, which is my website telling me that it can't connect to the downstream services, to the upstream services. So I get this 404 because that's just bad code that I've written, but it's telling me that it can't make that connection anymore. So I know that the network connection between my web and my backend services is broken. It's broken deliberately because Traefik won't allow that communication because I haven't set up the access control. Okay, so this is what access control looks like. There's two parts to defining everything. So firstly, what I'm going to do is bring everything onto my mesh, because in order to have that access control, Traefik needs to know about the destination as well as the source. And the way it deals with authentication is the same as Istio. If you saw the Istio episode, which was ECS-M4, it uses service accounts. So it trusts Kubernetes to provide the authentication mechanism to say, here's the service account that my caller is running under. Here's the service account that my target, my server, is running under. Let's make sure there's an ACL that allows that communication between those two parties. So firstly, I'll bring everything else onto the mesh, and that basically is just changing the URLs again. So for my Postgres database here, for my products API, I'm changing the Postgres to use Traefik.mesh as the domain. So it's going to get routed through my Traefik proxy. If I scroll down here because I've lost it, same with my stock API. I'm just changing the endpoints in the configuration to point everything through the mesh. And that's how I'm enrolling my services onto the mesh, and that's how I can apply my access control, anything else that I want to apply. Okay, so let's go and do that. So let's clear this down, and I'm going to apply my changes. Oh no, there's some other stuff in here too. Sorry, I only did through half my list. So also the services. For Traefik to understand the type of communication that's going through, the type of network traffic, it needs some help with that. So what I've got here is I've got these annotations that say this is HTTP. For my Postgres database, I've got an annotation saying this is TCP. For all the other services, we have this. So rather than explicitly modeling what the service looks like, the service detail, which some of the meshes do, with Traefik, you just add your annotation into your existing Kubernetes service definition. So my Kubernetes service here has just got these annotations. Everything else will ignore that, but Traefik will look for that and it'll understand how to build up its routing rules. Okay, so let's clear this down. So Moz says Traefik looks more efficient compared to Istio, compared to all of the other service meshes. Well, yeah, technically, because I've got one proxy per node instead of one proxy per pod. So I'm looking at, if my application landscape is any particular size, maybe I'm running 10 nodes on my cluster. I've got 10 proxies processing all this traffic instead of 100 proxies. So yes, but definitely something you want to kind of run some proper performance tests on that, because the flip side of that with Traefik Mesh, you don't have the sidecar, but you don't get all the features. So one of the things you don't get is TLS. You don't get mutual TLS between server and client because it doesn't have the injection of the networking layer at the right level. It's coming up here. It's more to do with routing than low level kind of traffic management. Okay, so let's deploy these things. So the secrets are telling the destination endpoints for all the targets to go through the mesh, and then those services are telling Traefik what type of traffic is going through there. Okay, so I'm going to restart my things to pick up the latest configuration, just to speed things up, and then I'm going to just double check that everything is up and running. So it's going to take a little while. So my products API, sometimes that fails because it needs to talk to the database. So if it isn't started in time, then that might be a problem. But it looks like everything's up and running. The new ones are running. That one's terminating. Where's my web component? The trouble with running watch is that you can't actually tell what's going on after a while. So let's have a look. Oh yeah, I didn't restart my web. That's fine. So my stock, my products DB, and my API. Okay, all good. So now if I try and do it again, it's still going to be broken because everything is on the mesh now, but I haven't still allowed any traffic. So the purpose of the ACL is to block anything that isn't explicitly allowed. So if you're not part of the mesh, then you're going to be blocked because you're not using the traffic. You're not getting access to the endpoint. And if you're on the mesh but you don't have the rules set up, then you're still going to be blocked. Okay. So now we've got everything that we need to have in place. We've got everything going through the Traefik mesh, just using that .traefik.mesh endpoint. And we've got the type of the traffic specified inside the Kubernetes service model. And we've got the destinations correctly configured for the URLs. Okay, so now then, the default is to deny all traffic. If I want to allow it, there's again 2 sets of things to do here. So firstly, I need to explicitly model the routes with these targets, with these SMI routes, and then allow the targets with the SMI targets. So if I look at HTTP get routes, this is the generic definition. So this is where SMI really kind of shines, because what I'm doing here in my API version is SMI spec. This is an HTTP route group, and standard Kubernetes specification. It's a custom resource, but it's deployed as part of Traefik Mesh. And it's also deployed as part of OSM if you use OSM. So I've got my metadata there, and what I'm saying is that this particular spec, it matches on HTTP traffic. It's just understanding the target for traffic, and for this particular thing, any destination for GET requests. So this is modeling what you're allowed to do. This is a permission model, really. So the permission to say you're allowed to make a GET request to any HTTP endpoint. That's what this route group gives you. Then obviously I need to apply that to a source and a destination, and that's what comes in with the target. But just to show you, also this applies to TCP. So I've got a TCP route. Again, it's part of the SMI spec for defining access to an endpoint. And there's no HTTP stuff in here because it's just TCP. So I'm getting layer 4 and layer 7 here. This is just specifying my port, my Postgres port. So these are decoupled from everything that's happening. I've just got a definition of a potential target for communication. And then when I specify who can allow to use those targets, that's in this resource here. So what I've got in here is my traffic target, again, part of the SMI spec. This is part of the access spec. And that's where I'm grouping together. I'm linking together those routes that I defined with the consumer and the server. So my rule here, so I've got my HTTP route group, my get all route, that's the thing I'm defining, where the destination is my products API. I'm going to allow access from my source, which is my website. So all I'm doing is I'm saying my web pod, that runs under a well-known service account called web. It's going to be allowed access to make a GET request to any HTTP endpoint to something that's being served where the service account is the products API. So it's an abstraction above the level of pods, because I can have multiple services that I'm using the same service account for. I'm specifying this authorization between those 2 authenticated principles. So my destination is my products API. As it happens, you've just got one pod that's using that service account, and it's going to be allowing access from my web pod to make any GET request. Of course, you can go down to fine-grained HTTP verbs and path regexes and all sorts of stuff to really control who can do what from different parts of your application. And further down here, almost exactly the same thing, but this is for when my destination is the stock API, exactly the same rule group. So these routing groups are generic things you can just piece together however you want to model your networking access, and the source is the website again. So the web component is going to be allowed when these are deployed. This is setting up the ACL to allow it to communicate with those 2 backend services, and then the services need to be able to talk to the database. So I can model that slightly more simply because I've only got one destination. The destination is where the service account is my products DB. So any pods that are running under that service account, this is how I can allow access to the traffic. My rule is my TCP route, which is the Postgres one. So that's just specifying my port. So I don't get that fine level of control because it's not HTTP traffic. The service mesh doesn't understand the packets, so it can't look inside them like it can with HTTP. So this is just at a port level. I'm allowing all access to the port, and the sources are either my products API or my stock API. So either of those sources can now talk into my database. So I've modeled my whole application authorization model. The website can talk to the stock API and the products API, and both of those can talk to the database, but nothing else. The website can't talk to the database and all that sort of other stuff. Anything that's not on the mesh couldn't make those calls either. Okay, so let's go and deploy this stuff. So if I deploy my routes and my targets, now in theory, this lives at a kind of abstracted level from my actual application, so I shouldn't need to restart my pods. But when I'm running this, it takes a while for them to take effect, so I just do the rollout restart for each of my components. I'm guessing there's, in order to optimize all these things, every network hop is going to check against the rules that are configured for the proxy. So everything is hyper cached to make sure that it's efficient as possible. And I guess that's why sometimes it takes a little while for these rules to filter through. But if you're in a rush, you can just restart everything. And now if I look and cross my fingers, yeah, everything's working again. So before I deployed Traefik, with the ACL configured. I had that set up to turn it on for this demo. So it blocked everything. And then gradually I brought my services onto the mesh, and then I modeled my authorization policies to allow the website to talk to the services and the services to talk to the database. And once that was in place, then everything went through the mesh and it allowed that traffic. So that's all working as expected. The other part that I get with the SMI, so there's three parts really. There's the authorization that we've just seen. There's traffic splitting, which we're just about to see, and then there's the metrics part, which Traefik Mesh doesn't implement yet, but a similar sorts of thing. You can record the kind of metrics you want to get from your application networking in an abstracted resource that applies to different service meshes. So we're just going to look at traffic splitting here. So let's clear some space again. Okay, and again, there's a custom resource definition, but it's defined at the SMI level. It's not a traffic. Definition. So inside here, I've got a couple of things. If you remember from the Linkerd episode, the way that traffic splitting works in SMI is that I've got these kind of top level service and the destination services. So I'm going to deploy a new version of my products API that increases the prices, and I want to kind of just send a few people to that endpoint and see if they still pay. And that will help me to just work out if that rollout is going to continue. So in order to do that, I've got a products API service, the top level service, and two lower level services. So this is how I could do a blue-green deployment if I was just using Kubernetes. I've got my top level service here, products API, and down here I've got products API v1 that is targeting that selector. So it's going to target just the pods that are running my v1 deployment. I've got products API v2 that's just targeting my v2 deployment. Again, just by labels, how you would normally kind of chain these things together in Kubernetes, nothing specific to SMI or traffic in here. Okay, now I've got my updated deployment. So this is my version 2 deployment. I seem to have managed to mangle my YAML there, so that's not going to deploy. So let's make sure that I fix that. Okay, so here's my updated deployment. This is my version 2 deployment. All it's got is the same application, but it's got this environment variable to increase the prices. If you've seen the previous episodes, same demo as before. So I have this new version that's not going to receive any traffic until I start shifting the traffic that way. And the way I do that is with this traffic split, and this is the SMI component. So this is an SMI resource definition. The traffic split is, I can call it whatever I like. And it's where the target service is products API. So this is the kind of the destination that the consumers are using. So when they're targeting that destination, actually 70% of traffic is going to come from v1 and 30% from v2. And this is how I can do my gradual kind of canary rollout. Okay, so let's go and deploy this stuff. So I'm kind of going through this fairly quickly because we've seen some of this stuff before with the Linkerd. It's exactly the same approach, and it's the same resource definition, which is the beauty of having that higher level SMI spec in there. Okay, let's go and deploy this stuff. So inside that update folder, I've got those new services defined. I've got my version 2 deployment defined. Right now, I haven't changed the traffic split, so I've got my new components up and running, but all traffic is going to my previous component. Let's just make sure that I've still got all the pods there. And let's do. Okay, so everything's up and running. So I've got my existing web, my stock API, and my new products API here that's just been running for 17 seconds. Okay, cool. So now when I deploy my traffic split, and again, so I'm deploying a generic SMI custom resource, and then it's the traffic mesh that's running here that's listening for those things and applying the rules that I put forward. So if I now go back to my site here and refresh, what I should see, this is always exciting when you're doing a demo and only some things only happen sometimes. There we go. So if you saw there, the price is here. This one is $45. So that's come from my version 2 pod. And if I refresh again, it goes back to 30. So most of my traffic is coming from my version 1 pod, and I'll see the occasional, higher price from my version 2 pod. So it works exactly the way you would expect, but the way you model that networking, it's at that abstracted level with the SMI, which is really nice, and that's the whole purpose of the SMI. Now, where it kind of falls down is where you then decide, actually, I'm using Traffic Mesh. I really like the lightweight parts of it, but there are some stuff that I need that it doesn't do. So, mutual TLS is an obvious one, and then collecting all the metrics for you is another one. It doesn't do that at the SMI level. So then you're going to go, well, actually, I've modeled out the networking for my application. I've got these SMI routes and targets and traffic splits. I've got all that. I'm happy with all that stuff. I can just take my application model, my networking model. My application model is standard Kubernetes. My networking model is SMI, and I can run up a completely different service mesh and just deploy that, and it will all work. And that's kind of where this kind of falls down a little bit. So I switch to a completely different cluster. I'm going to use Consul Connect. So Consul Connect It's a part of the HashiCorp Console product. So Consul is about service discovery. Consul Connect adds a service mesh features on top of it, and well, you saw its logo has appeared on the SMI website, but actually the SMI integration is a separate thing. So we're going to kind of go through and see how far we get, and we're going to stop before we get too much far down the rabbit hole. And then I'll talk at the end of today's episode about how you might evaluate some of these things and which service mesh is probably going to be the right one for you. Okay, so I'm switching to a different cluster. Again, I just created it with the kind create cluster. It's not doing anything special. There's nothing deployed on there yet. I'm going to deploy my demo 1 folder. So that's exactly the same version of the application that I started with. So completely fresh cluster. My other one's still running, but I'm not going to use it now. I've deployed my application without a service mesh. There's nothing else running, just my application. So if I go and check these pods here, clear some space. So it's taking a while for them to create again. So, it's kind of going to use my image cache, but it's double checking everything first. It's going to pull those images, make sure it's got the latest versions, and gradually they're starting up here. So there's my products API, my stock API, the database, and the website will start next. I'll get that error because it's trying to talk to the database, but it's going to kick off again in a moment, which is the advantage of a self-healing application that you get with your container orchestrator. Okay, so let's just clear this down. By the time I do this and look at it without the watch, everything's up and running. Okay, cool. Using a different port here, so if I browse to 31,000, same app, same Docker images, different cluster, working in the same way. It's the version 1 prices, as you see, because I haven't got anything else. I've just got the version 1 deployment in here. Okay, so now we're going to deploy Consul. Consul uses a Helm chart just in the same way that that Traefik does, but it's a lot more configurable. So typically, if you're going to deploy it, you'll want to set up a values file. If you're not familiar with Helm, Helm lets you define different variables that get injected into the Kubernetes manifest when it deploys them, and you can either set them with individual values like we did with the Traefik deployment when we set ACL is true, or you can give them a file, a YAML file, and say, here's all the variables that I want. So for my Consul deployment, that's what I've got here. I've got my Consul. I've got a really itchy nose today. Sorry if you're wondering what I'm doing. I'm stretching my nose. So this is my Consul deployment. I'm just going to run in like a dev mode. So I've got a single replica. I'm only expecting 1 replica. I've got a UI enabled. So Traefik Mesh doesn't have a kind of fancy UI yet, but Consul Connect does. So I'm saying I want that enabled. I'm going to use a node port because I'm running in kind, so I'm gonna expose it that way. And then this is the bit that actually turns into a service mesh. Connect inject enabled is true. So that's going to then inject those sidecars. So Consul Connect does work in the way that you would expect. And you would find from the other service meshes that there is a proxy container running inside the pod for each of your components that you bring onto the mesh. And that's what's applying the rules and the Traefik rules. So, but in theory, you should be able to use the same modeling with the SMI. Okay, so let's go and deploy this now. So I've already added all this stuff, but I'll just double check. So there's my repo for Hashi, and update my repo. So that's looking good. And now I'll do my Helm install. Nothing special about this. If you're not familiar with Helm, it's just I'm telling it to use that values file that we've just looked at. I'm telling it to go to HashiCorp's repository, which is where they store their YAML files, and install version 0.30 of the Consul application definition in Helm. So that's fine. It's all looking good. Let's clear this down. I've installed it into a custom namespace, so I'll make sure that everything is kind of in there. And there's a whole bunch of stuff that's running. So we've got the controller that's looking for my custom resources. I've got my webhooks, which are going to inject my my proxy pods inside my application pods, my proxy containers. Sorry. So right back in the beginning, we talked about how this stuff actually works. There's these webhooks in Kubernetes where you can inject new components into a model that's being applied. So every time a new pod gets created, my webhook gets called and it injects my proxy containers. That's the fundamental part of how Istio works and how all these things work, where there is a proxy container per pod. But what you will see, and this is one of the reasons why I'm using a different cluster, is if I look at the resource definitions, they're all Consul resource definitions. There's not any SMI stuff. So if you're looking at the current landscape and you're saying, well, SMI says we've got Consul Connect and we've got Traefik Mesh, so let's just compare the two things. This is where you're going to be slightly confused because the custom resources are not SMI resources. That SMI functionality comes in as a kind of a separate add-on to Consul that you install later. And the same is also true of Istio. you can add a connector which effectively adapts between the SMI definitions and the Istio definitions. And the problem with that is you can only go to the kind of lowest common denominator, so you can't express anything in SMI that your connector doesn't support in the ultimate service mesh, and you can't take advantage of the features in the ultimate service mesh by using just SMI, because SMI might not be able to express them all. So then you get into this kind of mix and match of having to translate between different things, and that's where the promise of the SMI starts to break down. Anyway, so we're going to plow on here. So we've got Consul installed. We're going to see what Consul can do. And then when it comes to finding out that we can't use our existing SMI models, we're going to call it quits. So if I want to look at Consul itself is really nice. And the fact that Consul doesn't do SMI by default doesn't detract from Consul. It's just highlighting the current state of the landscape. So SMI has got quite a high level of expressing what a service mesh can do, but not all the implementations are kind of giving it the full compatibility yet, and that's just the current state of the landscape. Okay, so I've got no SMI, but I've got my UI, so I can browse to this endpoint here. I get this really nice console endpoint. It's telling me the services it knows about. The term service is massively overloaded when you get into the service mesh space. There's Kubernetes services, but in this realm, Consul uses the word service to talk about things that it owns the discovery of. Right now, there's only Consul itself, but as we deploy things and bring them onto the mesh, they'll appear in here too. So my application is still running. It's on the same cluster, but it's not part of the mesh. They're not automatically being brought in. And one of the reasons for that is you can have your components being kind of automatically brought in, but Consul expects a few more bits of information, and really you need to model that inside your application definition. So you're probably going to have to explicitly bring things into the mesh anyway. So let me show you how that looks, because if I look at my deployments here, I've got a whole bunch of annotations. Let's get this as big as we can. So the first thing is this connect inject. So this is the annotations at the pod level, so within my deployment template. So I'm saying that I want to enlist into the service mesh. That's going to create my sidecar for me. So connect inject true means I'm going to be part of Consul Connect. And then I've got a service name. So the service name is how the service appears in Consul. So when you're doing the discovery and that sort of thing, this is the name that matters, not the Kubernetes service name. This is the Consul service name. And if you want to use interesting things like if you want to use ACL to enforce a kind of authorization policy, then the name that you have in here needs to match your service account name, which is a kind of, to me, is a strange restriction, and one that's just guaranteed to make you fall over in lots of different environments at different times. But that's a restriction of what Consul makes you do. So it can identify that this service, it's a way of looking up the authentication and matching the authentication to the runtime pod, so it knows that this communication came from this user, this principal, but it doesn't let you specify that. It just expects it to match the service name. And then the other thing that Consul does, which is different from all the other service meshes, is that you have to explicitly list the upstreams that your component is going to use. So the way that Consul works is much more like a kind of ambassador pattern, where the proxy container that's running inside the pod, it's serving up the endpoints on custom ports. So what I'm saying here is whenever my application pod makes a call to the products DB service, and again, that's going to be a service, a Consul service, ultimately gets sent to my Kubernetes pod. Whenever my application is referring to that, it's going to actually use a local host connection. So the proxy inside the pod is going to be listening on localhost 8097, and then it will direct that traffic according to whatever's configured in Consul Connect. So ultimately, it'll get to my database. But inside my application pod, I'm going to use a local host address. So you list out all of your upstreams and you give them basically a local alias, and that's what your application config needs to use. So inside my product API, I need to talk to my database on localhost 8097, which is kind of weird, and it's different from all the other service meshes. But just like with Traefik, where you have to explicitly change the URL to route things through the mesh, you're doing the same sort of thing with Consul, but you're explicitly using these local host addresses, which get proxied, which then take it through your proxy and then into the rules provided by Consul. And you can put metadata in here, so I'm putting my V1 metadata. The rest of this stuff's the same. I've just got those annotations in there. If I go and look at some of the other things here for my products database, Same deal, there are no upstreams for the database because it's the last thing in the chain. So I'm saying I want to inject to the service, and the service name is productsdb. So when my API is talking inside its pod to localhost 8097, ultimately it will route through to this pod because this is the console service name. So that link between my upstream in the API and my actual service here, that's what gets routed through through console. Okay. I've got all of them inside here, but just the last example, my website, I've got multiple upstreams here. So I'm injecting the service, I'm injecting to console. The service name is web, is my web component, and then my upstreams, I'm defining them all. So my products API will be available on localhost 8098, and that's going to proxy through console, and my stock API, localhost 8099. So different way of working. It seems, if you're used to Istio, it seems strange that you have to do that. But if you come from a different way of doing things, then I'm sure Istio seems strange. Okay, and then to do that, inside my configuration, I need to be using those local host addresses. So again, I've got config changes for all of my applications, but this is the products DB. So now I'm specifically saying the database lives at the local host at the address 8097, which of course it doesn't, but that's where the proxy is listening, and that's where it's going to send to the upstream. And same for my my website here, which I've got in this link here. My APIs, I'm using those local host addresses. And then that means everything's going to route through my proxy, and then all the rules that are defined in console are going to get applied. Okay, so let's go and see how this thing works. So I'm going to apply those changes, and that's going to update my secrets and my deployments. Because I've changed my deployments here with those annotations, I'm going to get new pods. So let's make sure that everything's up and running. And this is where we see console comes in, because console now they used to have, the previous version had one pod, and the new version's got 3 pods. So there's an init one container in the pod, and the new one's got 3 containers in the pod. So there's an init container that runs, sets up all the configuration for the proxy container, and then they're running as sidecars inside the pod. I'm still getting these errors from my products API, but I expect that because it's trying to talk to the database and it's not been set up yet. So ultimately it'll stop erroring and it'll run and it'll be okay. So let's check without the watch. And okay, all up and running now. They've all got these additional sidecar containers that are taking care of the proxying, but it should just work in the same way. So now if I go back to my console list here, oh, I had it for a second there. Now I've got everything's appeared. So it's all been brought onto the mesh. And because I map out the upstreams, console knows what my topology looks like without having to inspect any traffic at runtime. So without, with Istio, I can see that with Kiali, but it's building that service topology at runtime by looking at the traffic. Whereas console knows what the ultimate destinations are because they're all mapped out in those upstreams. So if I go and look at my web, it tells me that it can go and talk to my products API and my stock API. If I had my own little dashboard, I could service it inside the console UI, which is quite nice. Go and look at my products API, it knows it's going to the database. Products database, it knows it's being called by those 2 things. The instances are the list of pods that are running, and then there's a whole bunch of information down here about the various health checks that run, any metadata you're applying, all that stuff kind of comes through in here into the UI. Really nice UI to work with. Gives you all the kind of core information, and you can edit some of this stuff too. But then you're kind of mixing and matching your Kubernetes and your runtime edits. So you probably don't want to do that. So if I go back to my application, make sure it still works. This is the one. So let's refresh this. All works in the same way. So, the application is now being routed through the service mesh. I haven't applied any rules or anything like that. So, but now I've brought everything on. I can see it all inside my console dashboard, and then I can edit things and change my traffic and take advantage of the service mesh features. Now, this is where you then say, okay, that's cool. Let's take our SMI resources that we've already used in traffic and apply them here. And you're going to kind of fall into a documentation black hole because the documentation on the Consul Connect for the service mesh component doesn't really mention SMI. If you search for a bit, you'll find this, which is a GitHub project, and this is the adapter that basically tells you how to set up Consul to support SMI, and it runs an additional controller. That controller then is listening for the SMI resources, and it talks to console and creates the various things. And this is where you then say, this hasn't changed for 2 years, so I'm not sure I do want to deploy this in my service mesh. So this is the point where you're saying the SMI spec has moved on to a certain amount, the console features have moved on a certain amount, and the connector hasn't moved on. So you're wondering whether the adoption is actually really all there. Now that's fine. You don't have to go with the service mesh interface. You might at this point say, well, I really like console. We're using console elsewhere. We've got various hashy components. So we're just going to see how we model it in console. I'm not going to do all the demos, but they're all here if you do want to see it. You can get those same features, but you have to model them using the console resource definitions. So for things like authorization, again, I'm going to use service accounts as the principals, but here instead of defining it with root groups and targets, I'm using console's definition, which is an intention, which expresses here's my destination, my products DB, and I'm allowing access from the API and the stock API. This is at TCP level, so I don't go into a low level detail. But if I go on and do the same thing for my web connection, I can say for my website, the source of the website, I'm going to allow access to these HTTP endpoints for the name products API. And again, the service account is what provides the authentication mechanism. The name of the service is the console service name, and it applies these rules inside here. So I can still do my access control, but I'm remodeling. I'm not bringing forward my SMI stuff unless I want to rely on an adapter that looks like it was a kind of prototype project that didn't go any further. Same goes true for the splitters. So if I want to do my splitting, my 70-30 split, I need to define and model that using the HashiCorp resources. So the console resources that say, here's my products API, it's HTTP, so that it needs to know that to understand about, it can look inside the traffic. I've got my service resolver that defines these subsets. So it's looking a lot more like the way Istio models this stuff with my destinations and my subsets. And then inside here, the last thing is the splitter. And that's what's saying when you talk to products API, 70% of traffic is going to subset V1, 70% and 30% to V2. And that's driven by the version metadata inside the console service. So your console service metadata as opposed to your Kubernetes metadata, which brings up a whole nother question about where you put these things and potential issues down the line. But that's something else you need to think about. Okay, so all those demos there, if you want to go ahead and do it yourself, you can. I'm not going to do it because we're already kind of running out of time. And I wanted to finish with a little bit of guidance because several questions have come up during these episodes saying, which one should I pick? And really, really, I was hoping to finish off SMI on a slightly higher note than I have. If you use OSM and it works for you, then it's still a beta project, but it supports the full SMI. So that might be a different story for your applications. But from my point of view at the moment, like I really think SMI is a great idea. What it's trying to do to give people flexibility with different implementations is the way we work in IT. So that's great. But right now, it's not kind of there, and it's been not there for a little while. So I'm not sure if there's enough kind of energy around to get SMI adopted in a big way. OSM is nice, but it's still pretty early. I couldn't get it to work with my demo application, but again, your mileage may vary. It supports the SMI spec. It does a lot of the features that you expect. It does the mutual TLS and the observability and all that stuff. I was originally going to demo it, but I couldn't get it to work, so there's nothing to demo. So, so I come down to my choices here. I think the main choices, if you're looking at these things, Istio, Linkerd, and Consul. I think the choices are pretty simple if you're new to all this. If you're already using Consul, then go with Consul Connect because you're already working with the HashiCorp stack. You know that Consul stuff, when you run it in production, you need to run multiple server nodes and all that sort of stuff. If you've already got that, then you might as well leverage what you get with Consul. Forget about the SMI stuff and just learn the way that Consul models those things. You can put them all in Kubernetes resources, so they all live with your application, and you can deploy that running it locally and have the same rules applying in all your environments. If you're not using Consul, and if you're pretty good with Kubernetes, so you're happy with the complexity of Kubernetes as it is, and maybe you want to take on some more complexity, then I think Istio is the obvious choice if you're not worried about the governance issues. So if you remember when we saw that in ECS-M4, there's a kind of cloud, excuse the pun, hovering over Istio about the potential future direction of the project. But people have been kind of muttering about that for a few years now, and nothing bad's happened. So unless you have got a particularly low appetite for taking on a project and not knowing the governance of it, I think Istio is probably the way to go. Otherwise, I would choose Linkerd. So if you don't have if you're still fairly new, or your team is fairly new with Kubernetes, you don't want to take on all the extra complexity, or you don't like the governance around Istio, or you want to really fine-grain down on performance, then Linkerd is a good choice. So for me, it comes down to those three. I would love to see SMI kind of take off and everything else implement it, but it's not right there right now. And the last thing I will say about all this stuff is all of these projects have their own demo application. So with Istio has the bookstore, OSM has a kind of rival bookstore, Linkerd has got the emoji application. don't spend very much time with those because all of their demo stuff is shown to the demos they walk through are there to highlight the features of that service mesh. So by all means, spend an hour looking at a demo app, and then as soon as possible, switch to your own applications, because that's when you'll find that things kind of don't work as you expect. So yeah, look at the demo projects. If you're thinking of getting up and running with one of these technologies, spend a little bit of time on it, and then get your app as soon as possible and start modeling the real things that you want to do. So that's kind of important. Okay, yeah. So Balor's answered my question there, which was about mesh. So that's it for service mesh. We got one more month. So next, for the rest of this month, I'm going to be talking about security topics. So pretty important stuff around about securing your applications and the ability you get with containers to secure at different levels. So you can you can be sure that the package is secure by looking at your images. So some interesting topics we're going to cover. So stay tuned for that. That's coming up next week. We'll be looking at runtime security, security, vulnerability scanning inside your packages, a whole bunch of cool stuff you can do. So thank you for joining this week. I hope it was useful, and I will see you next week to talk about security. There'll be 4 episodes. And then at the end of April, so at the end of March, we are switching to the Kubernetes live stream. I'll do that all through April. So 4 more episodes of the Container Show, and then we're switching to the Kubernetes show. So hope to see you next week, and I hope you found this useful.